Okay guys, this is a video as promised to talk about being able to do the GPIO export on your project in code rather than have it done in the project itself. So let's go and take a look at the original project here on Visual Studio. And if we go to the project itself, we select properties and then we go to remote post build event. You will see that we have the GPIO export 17 on there, or GPIO export 17 out, and the out means it's for output. So having said that it's in there, let's go ahead and run this to see how it reacts with the Raspberry Pi and the blinking LED. And as you can see, it starts to blink. Now, we would like to be able to do this in code because it will make our code itself a little more transportable or portable in the future. So if we close this down and then we go over here to the properties again, and let's delete this. Okay, so let's take that out. Apply that, and then we'll say OK. Now if we go back to our project again and we run it again without the GPIO export command, let's run that and see what happens. Okay, it comes up, it connects, and oh wait a minute, it's still blinking. Okay, what happened there? Well, what happened was that we had already initialized the program and it's still in memory and it's still running. So when we fire it up, it comes up and it starts blinking again. So we got to do something to clear that out. So let's close or shut down the Visual Studio for a second, and let's bring up a program called Putty. Now you can use other methods of connecting to your Linux box, but this one is the easiest one for a Windows user. And I've already set up the connections to it, but if you're going to do Putty, then Raspberry Pi, in this case my host name is Raspberry Pi, yours may be a IP address, whatever it suits you, and I'm using port 22 and SSH to connect to my Raspberry Pi. You may have something different, but this is pretty standard and it's probably something that you can use. So having said that, let's go ahead and open up our connection. And you have to log in. My particular Raspberry Pi has a username of Pi, and then you put in your password and you make a connection. Okay, let's just check to see if we've got something in there, and we do. So now that I've done that, I'm going to have to reboot this Raspberry Pi. So let's do a sudo reboot command, and when I do this, it's going to lose connection and you'll see an error pop up, and as expected, remote site unexpectedly closed because the Raspberry Pi is rebooted. So we'll close that out. We'll close out the Putty for this particular moment, and we'll let the Pi start to reboot. A good way to check to make sure that the Pi is going to come back up is to bring up your Putty again. In my case, I've already created a file for Raspberry Pi 3 to load it. We'll give it a few seconds. You'll notice that the green LEDs are flashing on the Raspberry Pi 3. That means it's starting to go through its reboot process. Give it a few more seconds, and let's give it a try. If it doesn't connect, which in this case it did, it would come up with an error and you'd have to retry. You'd have to shut down the Putty and retry it again. But so let's verify that we are now back into our Raspberry Pi 3. It comes up and there we are, we're back in. So now we've got a reconnection. We rebooted and we reconnected. We'll minimize that for a second. Now let's go back to the project again, check properties. The GPIO export command is deleted as we had originally started with. So let's go ahead and run it again. you'll see that we did get a Linux console, as we're connected to the Raspberry Pi 3, but you'll notice that the LED is not blinking. That's because the program doesn't have the GPIO export command to make that particular pin blink. So, how do we do that in code? Well, let's go back and let's close this out. Close out the Visual Studio. And let's go ahead and add some commands. First thing you need to do is come up to the top and do an include statement for the IO stream library. And then next we're going to go into the main code and we're going to add a command called system. Now this one is pretty simple. Type in system, then you got your parentheses, you put in quotations the command that we had already had in our project, and that is GPIO export 17 out for output. Now another thing that should be noted that this command should be in front of or before the wiring Pi setup sys. If you move it down below, you'll have some problems, and that makes sense because in your project folder, that command that you had in there before under your remote post build was actually a command that would be initialized before the program is started up or during the startup of the program. So you would want that at the beginning of your code. So now that we've added this particular command, let's try it again. We'll click on the start button. It's going through some code initialization, linking. We should get our Linux console window down here. Since it connects, it did connect. And if you look over at the other video, you'll notice that the LED is now blinking, which is exactly what we wanted. So let's shut that down again. And you'll notice that the LED stays on. That's just an anomaly from the code being initialized either as a high or a low output, and it stays at that particular mode. If you tried it again, let's try it again, you might get lucky and actually have it shut off. Let's see if it does it. So we're running the program again. You'll notice that the LED is blinking, and depending on when I shut it off, you can have it turned on or turned off. Let's see what happens. In this case, it stayed on again. It really doesn't matter. You can always we can always go back and reboot. So if we went back to our Putty and we do a sudo reboot, you reboot the device, and let's see if we get the LED to go out. Yes, it does indeed. Okay, so there you go. That eliminates the command in your project folder that you would have had in properties that would have been here under the command line. That's now gone, and the command is initiated within your code, making the code much more transportable or portable for future use. Now, just a comment about C++. Some people may say, well, why C++? I mean, it's kind of it's an older language, it's more antiquated. Well, here's the thing. If you're going to do like embedded systems, very small hardware embedded in very specific capabilities, and I've done this in the past, and as an engineer I've done it many times with hardware-software integration, you need to get down there at the very, very lowest nuts and bolts on the rails of the particular hardware. And if you're going to do that, C and C++ give you very, very low-level access to the hardware. And that's why C++ and C are very valuable languages. They're very fast, they're very tight code, right down there at the very lowest level, and it gives you a lot of control over your hardware. And that's why you would use C or C++. So that's it for this video, guys. It's pretty simple, but as promised, I gave you a way to do this in code rather than have it embedded in your project, which I think is less transportable. So hope you enjoyed this, and you all take care of yourselves, and we'll talk to you next time. Goodbye.